Hi, in this video we are going to use elimination method to solve a pair of linear equation. So let's write down the linear equations first. The first linear equation is 2x plus y is equal to 6, and the second linear equation is x plus 4y is equal to minus 4. Now let's call this equation as equation 1 and this as equation 2. Now in elimination method, we have to remove one variable from the equation. That means if we remove x from the first equation, the equation will be in variable y form only and will get the value of y. Now if you want to remove the variable x from the first equation, what we have to do? We have to subtract 2x from the left hand side. That will eliminate the variable x. Now how we can make use of the second equation? Second equation has also term x, and if you multiply equation 2 by 2, then the equation will have the variable 2x. So let's multiply equation 2 by 2. So what will happen? We are going to multiply equation 2 by 2. So 2 into x plus 4y is equal to 2 into minus 4. As we are multiplying both sides by same number, the equation will be in balance. So if we add, subtract, multiply or divide by same number to both sides of an equation, the equation will not change. It will be in balance. So let's simplify this equation. 2 into x will be 2x plus 2 into 4y will be 8y. That will be equal to 2 into minus 4 is minus 8. So let's call this as equation 3. Now we got first equation 2x plus y is equal to 6, and the second equation is 2x plus 8y is equal to minus 8. Now it is clear. Looking at both the equation that it has same x term. So if we subtract equation 3 from equation 1, then the variable x will get removed. So let's subtract equation 3 from equation 1. So let's call this as step 1. In the step 2, we'll subtract equation 3 from 1. So let's write down the equations again. So the first equation is 2x plus y is equal to 6, and the third equation is 2x plus 8y is equal to minus 8. This equation is nothing but same as the equation 2. So just we multiplied by 2 to both sides so that we can remove one variable. Now to remove 2x, we need to subtract both the equations. So let's subtract. Now in elimination method, we have to write one equation below other equation to make the subtraction easy. So plus will become minus, then minus will become plus in this case. So 2x and minus 2x will cancel each other. So what we'll get? Y minus 8y is minus 7y is equal to 6 plus 8 is 14. Now if we divide both sides by minus 7, we'll get y is equal to minus 2. So this is the value of y we found out using eliminating variable x. Now to find out value of x, either we can put value of y in equation 1 or equation 2. Either way will give the value of x. So let's put value of y in equation 1. So what is the equation 1? 2x plus y is equal to 6. Now 2x will remain as it is. What is the value of y? Y has value -2 is equal to 6. Now adding 2 to both sides will give us -2 and +2 will cancel out. 6 plus 2 will be 8. And if we divide both sides by 2, we'll get x is equal to 4. With elimination method, we got the solution of these linear equations as x has value 4 and y has value -2. So in elimination method, you have to find out suitable variable to eliminate, and according to that, you have to convert the equation such that the variables get removed. In this case, we multiplied equation 2 to remove the variable x. Now in this equation, suppose we want to remove the variable y. Then if we multiply equation 1 by 4 and if we subtract equation 2 from 1, we'll get value of y. So as we are removing or eliminating variable from the equation, this method is called elimination method. In the previous example, we eliminated variable by subtracting one equation from another equation. Now this is a different case. Let's write down the linear equations first. 2x plus 3y is equal to 2. So this is our first linear equation. And the second linear equation is 3x minus 2y is equal to 16. To eliminate variable y, we have to multiply second equation by 1.5 or 1.5. If we multiply minus 2y by 1.5, we'll get minus 3y, and 3y will get cancelled out after adding two equations. However, instead of working with fraction, let's multiply. Let's multiply equation 1 by 2. So we'll multiply equation 1 by 2 and equation 2 by 3. If we multiply first equation by 2, we'll get 6y over here, and if we multiply second equation by 3, we'll get minus 6y. So both the terms will cancel each other and y will get eliminated. So let's multiply equation 1 by 2. So what we'll get? 2 into left hand side of the first equation is 2x plus 3y is equal to. Now as we have multiplied left hand side by 2, we have to multiply right hand side by 2 as well. So 2 into the right hand side of the first equation is 2. So let's simplify this equation. 2 into 2x is 4x plus 2 into 3y is 6y is equal to 2 into 2 is 4. So let's call this as equation 3. So we got a new equation. Now the second case is we have to multiply equation 2 by 3. So what is equation 2? Let's multiply it by 3. 3 into left hand side of the equation 2 is 3x minus 2y. Okay, as we are multiplying left hand side by 3, we have to multiply right hand side by 3 as well, so that the equations are in balance or the equation will not change. So let's simplify. So 3 into 3x is 9x minus 3 into 2y is 6y. So we'll get minus 6y. That is equal to 16 3s are 48. So we got another equation. Let's call this as equation 4. Now if you look at equation 3 and 4, we can see that there is a common term 6y in both the equation. However, their signs are different. To cancel out the y term, we have to add the equation 3 and 4. So let's add equation 3 and 4. So in the first example, we subtracted one equation from another. In this case, we are adding the two equations to eliminate the variable. So the equation 3 is 4x plus 6y is equal to 4. Now let's write down the equation 4 below the third equation. That means 9x minus 6y is equal to 48. Now let's add these two equations. So 4x plus 9x is 13x. 6y and minus 6y will cancel each other, equal to 4 plus 48 is 52. Now if we divide both sides by 13, we'll get 4. 13 fours are 52. So x has value 4. Now let's put back the value of x in either equation 1 or 2. Either way it will work. So we'll put in equation 1, putting x in equation 1. So what we'll get? Let's write down the equation 1 first. 2x plus 3y is equal to 2. That means 2. What is the value of x? We calculated the value of x as 4. Plus 3y is equal to 2. That means 8 plus 3y is equal to 2. And we subtract. And if we subtract 8 from both sides, we'll get 3y is equal to minus 6. Let's divide both sides by 3. So we'll get y is equal to minus 2. So we got the value of y as well. Hence solution of this equation is x has value 4 and y has value minus 2. Now let's discuss some special cases. We are having two linear equations, 2x plus y is equal to 6. Now let's call this as equation 1 and the second equation as 4x plus 2y is equal to 12. Let's call this as equation 2. Now to eliminate variable y, we have to multiply equation 1 by 2 and we have to subtract equation 2 from 1. So let's multiply equation 1 by 2. So the equation will become 2x into 2 is 4x plus y into 2 is 2y is equal to, so we have to multiply right hand side by 2 as well. So 6 2s are 12. Now this is our equation 3. Now let's write down the equation 2 as it is. So equation 2 is 4x plus 2y is equal to 12. Now if we subtract the second equation from the third equation, what will happen? 4x will cancel each other, 2y will cancel each other, 12 and 12 will cancel each other. So we'll get 0 is equal to 0. Now when we multiplied equation 1 by 2, we got the same equation as second equation. Hence these two linear equations represent one and the same linear equation and they will have infinite number of solutions. So these two linear equations has infinite solutions and they are nothing but graphically coincident lines. Hence these equations are called as dependent linear equations. So this is a case of dependent linear equations. Now let's discuss about another case. The linear equations are 2x plus y is equal to 6 and 4x plus 2y is equal to 6. Let's call this as equation A and this as equation B. To remove variable y from the equation, we have to multiply equation A by 2 and subtract equation B from A. So let's multiply equation A by 2. So the equation will become 2x into 2 is 4x, plus 2 into y is 2y, and 6 into 2 is 12. Let's call this as equation C. Let's subtract the equation B from equation C. So what is the equation B? It is 4x plus 2y is equal to 6. Now we have to subtract this equation. Signs will change as we are doing subtraction. So 4x and 4x will cancel each other. Then 2y and 2y will cancel each other. So we'll get 0 to the left hand side is equal to 12 minus 6 is 6. But this is not correct. This is not correct. Hence, these two linear equations don't have any common solution. So there is no common solution to these equations. On graph, the lines representing these two equations are represented by parallel lines. So these are parallel lines, and the equations, as 0 is not equal to 6, this is a case of inconsistent pair of linear equations. So these two linear equations are inconsistent. So these are the two special cases of linear equations.